We're going to talk about hypothesis testing for a one sample mean test. And we're going to have a scenario about pizza delivery times. And in this video, we're going to specifically talk about making the hypothesis and a little overview of all the steps to hypothesis testing. So let's say there is a pizza place that claims that their average delivery time is 30 minutes with a standard deviation of 15 minutes. Now, that's a good amount of time for pizza delivery, but let's say you question this claim and you really think it's much longer. Say you think it's about 40 minutes. So you want to do a hypothesis test to test their claim that the average time is 30 minutes. Their claim was that it was 30 minutes. The population mean of delivery times is 30 minutes. That was their statement. But our hypothesis as a researcher or as a customer is that we hypothesize that the actual average is more than 30 minutes. We think that their claim is wrong and we think the average time is actually higher. So we go out and do a hypothesis. Alright, so we go out and do a hypothesis test, and I have this question for you. Can we prove our research hypothesis to be true? And the answer is nope. Well, nothing is 100% first of all in statistics and inferential statistics, because we are basing our statements about a population from just a small subset of the population, which is our sample. But there's another thing that is wrong with trying to prove our hypothesis is true. Now, I'll take an example from Karl Popper. This is him. He was a philosopher. And Karl Popper said that all swans are white cannot be proved true by any number of observations of white swans. We might have failed to spot a black swan somewhere, but it can be shown false by a single authentic sighting of a black swan. Scientific theories of this universal form therefore can never be conclusively verified, though it may be possible to falsify them. So he says that we can falsify a hypothesis, but we can never really prove a hypothesis. So that makes our hypothesis testing a little strange. But we can still kind of test our research hypothesis in a roundabout way. The first step to a hypothesis test is to make the hypothesis, and you're going to have two different hypotheses, and they're competing. So the first one is the null hypothesis. And that's kind of what they were claiming, that the population average delivery time, DT, is 30 minutes. It equals 30 minutes. And our null hypothesis, which is H0, that's how we're going to denote it. It's always going to be the population mean, and you can put the subscript if you want. And it's not always going to be DT, but DT stands for delivery times, and it's going to be equal to, and your null hypothesis always equal some number, and the number is of some importance, and in this case it was the pizza place's claim. It was 30 minutes, so it's kind of obvious, but other times it might not be so obvious. Sometimes this number is from past research. You know that in the past ACT scores are around, say, 21. But you want to know if all of a sudden it's got easier. And for this year, the ACT scores actually have a higher average. So you would say the population mean of ACT scores equals 21 here in the null hypothesis. So it's some important number, but it's not your sample mean. It's some important number that you want to compare your new sample to. And this is the hypothesis that you want to prove false, right? This is their claim that it's 30 minutes and you want to prove it false. And again, the null hypothesis always has the equal sign, equals some number. The population mean equals some number. And also in step 1, you want to write a research hypothesis, or it's called a alternative hypothesis. So instead of writing some specific research hypothesis that it's equal to something specific, some specific number, we write a research hypothesis in opposition to the null hypothesis. So it's in opposition to the null hypothesis. Now, if you find evidence to reject the null, right, that's what we want to falsify. Karl Popper said we could falsify something, but we can't really prove it. But if we falsify the null hypothesis, then our opposition hypothesis, which is the research hypothesis, is probably true. See, it's a little roundabout way, but that's how we have to do it. And when we calculate things, it's really about the null hypothesis. But if we say there's enough evidence to falsify the null hypothesis, then our alternative hypothesis is probably true, or our research hypothesis is probably true. Now, for the research hypothesis, you're going to have 3 options. So we're going to denote our research hypothesis with H1, and then you say the population mean could be less than that same number from the null hypothesis. You can say it's greater than that number or not equal to that number. So if you say it's less than that number, then maybe that would be like if the pizza place thought, oh, they have a new system of making pizza, they have a new oven, and it takes less time to make the pizza, so they actually think their pizza delivery time is lower than what they claimed before. So that would be like the first option. The second option is what we were talking about when we said that we thought the average time as a customer was actually longer because we ordered it a few times and it took like 40 minutes each time. And then the not equal to would be if we were kind of in the middle and we're this independent researcher and we don't have a specific research hypothesis. We just saying that it's not equal to 30 minutes. So that could be less than 30 minutes or greater than 30 minutes. We're not deciding which one. And you want to look for keywords in the example to understand what the researcher thinks is true. Now for us, right now, we thought it was actually greater than 30 minutes because we thought it was taking a long time. We went over step 1, but there's more to a hypothesis test than just making up the hypothesis, right? We have to actually test them. So we're going to create our hypothesis about the population mean. Now notice when I wrote the hypothesis, it was always about the population mean because that's what we want to make our inferences about. We want to make our statements about the population mean. You know, we don't really care about our specific sample mean, but we can't have access to the whole population. So we're going to base our statements about the population based on our sample mean. And what we're going to do is take some information, our sample mean, our sample standard deviation, our sample size, and we're going to put it in little formulas, and out comes our t-statistic. And then we're going to put our t-statistic into Excel, and we're going to get a p-value, which is our probability value. We could also get a z-statistic and also get a probability if we knew the population standard deviation. So basically the middle is just math. Okay? So we create our hypothesis, and then we do some math. And then based on our p-value, our probability value, we make an inference, which is a statement about the population based on the p-value, which this is called the conclusion statement. If our p-value is really small, and we'll define how small it has to be a little later, then we have support for our research hypothesis. If it's really small, then we say our null hypothesis is false, and we have support for our research hypothesis. Remember, the null hypothesis and the research hypothesis are in opposition of each other. Here are the steps to a hypothesis test. There's 5 steps. The first step is to state the hypothesis. You'll have 2, the null and the research hypothesis. Then you want to check the central limit theorem assumptions, because if we don't have these to be true, then we really can't calculate the p-value, because we need to know if the sampling distribution is normally distributed. Number 3, we want to set an alpha level, and this is the level that we're going to compare our p-value to, our probability value that we calculate. And step 4. So you want to set the alpha level before you calculate the p-value, and this alpha level is just the level at which you say the p-value is small enough to say that our null hypothesis is false and that we support our research hypothesis. A common one is 0.05. And then at step 4, we calculate the t or z statistic, and based on the t or z statistic, we calculate the p-value. And number 5, we make a conclusion statement, and we say if we support our research hypothesis or not, based on whatever the p-value was. So we make kind of an educated guess about the hypothesis that we made in 1 based on our p-value.